You are looking at a hedgehog, and not just any hedgehog, an albino hedgehog, which is a very rare trait to be found in any organism, including hedgehogs. Let's say we wanted to know more about how this trait is inherited. Well, we could use information from a diagram known as a pedigree to figure out how inherited traits, like albinism, are passed down from one generation to the next. And these diagrams are great because they show us which members of a family have the trait and which don't, and they can allow us to solve mysteries about inheritance patterns. So first of all, let's take a look at how to read the pedigree diagrams. Circles always indicate females. Squares indicate males, and anytime you see a horizontal line connecting them, as in this case, that shows that they are mating. Let's take this a little bit further. If you see, in this case, a vertical line connecting from the mating, then you've got offspring being connected to the parents. So here is our vertical line connecting the two parents to their children. You can see that this child is a boy because he's square, and this child is a girl because she's circular. Another interesting thing to note is that the trait that we're studying will always be shaded. So this individual here, this son, has the trait we're interested in. One important clarification though, the shaded trait is not necessarily a recessive trait. Many students often think that the traits studied are always going to be recessive, and that's not the case. A shaded trait could be a recessive trait, or it could be a dominant trait. And one of our goals will be to figure out what kind of trait it is. So what can a pedigree tell us? Well, first of all, it can tell us where the gene is located. Is it located in an X and Y chromosome, meaning a sex-linked pattern? Or is it located on an autosome, chromosome pairs 1 to 22 if you're a human? Pedigrees can also tell us how the gene is expressed. Is it a dominant gene, where you only need one allele to express the trait? Or is it a recessive gene? You need two alleles or a lack of the dominant allele to express the trait. Let's see if we can use pedigrees to answer this question. So first of all, a couple important patterns here. If you see a pedigree that's showing a dominant trait, you will most likely see that the dominant trait appears in every generation. It's in generation 1, it's in generation 2 a few times, and it's in generation 3, right here and right here. So if you see a trait appear in all generations, it's most likely a dominant pattern. If, however, you see that the trait skips generations, for example, in this pedigree, you can see that it skipped generation 1 and generation 2, that's a big clue that you're dealing with a recessive trait. This trait doesn't pop up until generation 3 and generation 4. What about where the gene is located? Well, if we're dealing with the sex-linked trait, you'll likely notice that mostly males are affected by the trait. In this pedigree, you can see that all 3 affected individuals are gentlemen, as opposed to females. On the other hand, an autosomal pattern will likely affect males and females more or less equally. In this pedigree, you can see that there are 1, 2, 3 affected males and 1, 2 affected females. 3 versus 2 is not a significant difference, so we could conclude that this is an autosomal pattern. Now, if you look again at the pedigrees, you'll see that they're both recessive, because in this case, generation 1 was skipped with a disease, and in this case, both generations 1 and 2 were skipped with a disease. So now let's take a look at some real syndromes. The first one we're going to look at is Marfan syndrome, which has some interesting consequences. This syndrome affects connective tissue and results in an elongated skeleton, dislocated eyes, and heart problems. Some scientists think Abraham Lincoln had this disease, but there's really no proof. He might have just been really tall. Well, let's figure out how this is inherited. Looking at this pedigree, I'm going to ask myself a couple of things. First of all, is the trait expressed equally in both sexes? Well, if I look through, I see that there's 1, 2, 3, 4 women with the trait, and 1, 2, 3 men with the trait. Well, that's more or less equal, so I'm going to conclude that this is an autosomal trait. Now I'm also going to see, is the trait expressed in every generation? Well, it's in generation 1, it's in generation 2, and it's in generation 3. Since it's not skipping generations, I'm going to conclude that this is a dominant trait. All right, there's our first case study solved. Let's go to the disease of hemophilia, which affects blood. Here's a pedigree for a family with hemophilia. First thing I'm going to ask myself, is it expressed equally in both sexes? Well, looking at this, I see that 1, 2, 3 males have the disease. Because it's affecting only males, I'm going to conclude that this is sex-linked. I'm also going to see, is it expressed in every generation? No, it's not. It actually skips generation 2, which suggests that this is a recessive disease. Let's do one more, the case that started this whole study, albinism, which can affect not just hedgehogs, but many other organisms, including humans. Here's a pedigree for albinism. Again, is the trait expressed equally in both sexes? Well, looking at this, I've got 1, 2, 3 males affected and 2 females affected. That's pretty equal, so I'm going to assume that this is autosomal. It is located somewhere in chromosomes 1 through 22. Now I'm going to ask myself, is the trait expressed in every generation? Well, I see it expressed heavily in generation 2 and in generation 3, but it actually skipped generation 1 entirely. This suggests that the trait is recessive. Most likely, both of these parents are heterozygotes and passed one recessive allele each down to their affected children. Now that we know how to analyze pedigrees, we'll take a look at more challenging problems tomorrow and use these pedigrees to figure out the genotypes of all individuals.